In the previous podcast, we looked at how to determine how many digits in a number are significant. What we're going to do in this podcast is go over the procedures for using significant figures in calculations. In other words, when we multiply, divide, add, or subtract, you have to take into account rules for using the proper number of significant digits. So what we will do is go through each of the mathematical operations. So let me get myself a pen here and we will get started. Alright, the first thing we're going to do is look at multiplication and division. Multiplication and division follow the same rule. What you're going to do is count the number of sig figs in the problem. The one with the fewer number of sig figs determines the number of sig figs in your answer. So for instance, let's do this problem here. We have 4.56 times 1.4. If you do that in your calculator, you get 6.384. So what you want to do is count the number of sig figs in each number in the problem. So this one has 3. This one has 2. Since 2 is the smaller number, our answer has to have 2 significant figures. So counting left to right, 1, 2, you're going to round to that digit. So our answer here is going to be 6.4. We're not going to go into the reasons why you have a specific number of significant digits in a math problem. We're simply going to go over the rules in this podcast. Alright, let's take a look at the next one. And you can see it's a division problem. Now when you have a number written in scientific notation, the number of sig figs are determined by what we refer to as the coefficient. So 1.05, this number has 3 significant digits. Remember, trapped zeros are significant. This number has 4 significant digits. So let's do the math. 1.035 times 10 to the negative third divided by 6.135, and we would get 1.7115 times 10 to the negative fourth. Our answer has to have 3 sig figs, so 1, 2, 3. Our answer would be 1.71 times 10 to the negative fourth. Alright, let's take a look at the next one. A division problem. 2 sig figs, 5 sig figs. Put the number into the calculator and we get 0.08359, etc. So our answer is going to have 2 sig figs, so counting left to right. Now remember, leading zeros are not significant, so we're not going to count that one. So 1, 2, we're going to round to that place, so 0.084. Just to review our rounding rules, if the digit to the right of the one we're rounding to is 5 or greater, we're going to round up. If it's less than 5, we're going to round down. Alright, the next thing we're going to look at is addition and subtraction. So just as multiplication and division followed the same rule, addition and subtraction follow the same rules. And this one's a little bit trickier, but not much. Alright, when you do addition and subtraction, you are not following the same rule. What you're doing is you're looking at placement. So in other words, we don't care that there's 2 sig figs and 3 sig figs. What we care is the placement of the last digit to the right. In other words, this place is the ones place. This place is the tenths place. We pick the placement that's least precise. In other words, the ones place is less precise than the tenths place. If you think of it as something on a number line, if that's your base, the ones place would be here, the tenths place would be here. The placement furthest to the left is the least precise. Or you could think of it as just precision. The ones place is less precise than the tenths place. So our answer has to be at the ones place. So when we do the math there, we're going to get 7.2. But our answer has to be rounded to that place. So what we're going to say, the answer is 7. not the 7.2. Alright, let's look at our next problem here. We have 12.11, 18.0, and 1.0113. And this is an addition problem. So we have the hundredths place, the tenths place, and the 10,000ths place. Well, the tenths place is the least precise placement, so our answer is going to be rounded to the tenths place. Again, remember, I did not count the sig figs, I'm just looking at placement. So 12.11 plus 18 plus 1.0113 is going to give us 31.1213. We're going to round to that place, so our answer is 31.1. Alright, up here, if we look at the third one, we've got the thousandths place, the hundredths place, and the 10,000ths place. So our answer is going to be rounded to the hundredths place. 21.901 minus 13.21 minus 4.0215. We get an answer of 4.6695. And again, we're going to round to the hundredths place. So we have to round that to a 7, so we would, or I'm sorry, to a 7, so we would have 4.67 as our answer. Alright, if we look at the next type of problem, you sometimes have addition, multiplication, all combined into one problem. So what you want to do here is use your rules for each part of the problem and complete the problem that way. So let's do the subtraction part first. First of all, they're both to the hundredths place, so we're going to round to the hundredths place. So we get 1.11. Let's do our multiplication here. We essentially have 4.184 times 100.62 times 1.11. 4 sig figs, 5 sig figs, and 3 sig figs. So since these are all multiplication, our answer is going to have 3 sig figs, so 4.184 times 100.62 times 1.11, we get 467.3. Round to 3 places, 1, 2, 3, so our answer would be 467. Alright, again, just to review, multiplication and division, we count the sig figs in the problem. Our answer has the number that's equal to the lower number of the 2 in the problem, or 3 for that matter. And addition and subtraction, we're looking at placement, not the number of digits in the problem. You want to remember these rules so as we work through the year and you're required to use sig figs, you'll get the right answer according to the sig figs.